Hi guys, welcome back to Math with OG. In this video, we'll be looking at identity element of binary operation. If this is your first time here, kindly use the subscribe button and don't forget to like the video if you enjoy the video. Now let's move on to identity element. A set K is said to have an identity element. You can say it's said to have an identity. Okay, let me just add element to it. An identity element. So from this first statement, you can see that not all operation has identity element. Not all operation has identity element. So a set K is said to have an identity element under a commutative binary operation. Under this operation. So this set is said to have an identity element under this operation if for all values of x, if for all values of x being member of the set and also the identity element still being member of the set such that x operation I is equal to I operation x is equal to x. So I've defined my identity element to be equal to I. In other textbook, they define it to be something else. I define mine to be I. So if for any time your x, an element from that operation, is operating on I, is equal to if I is operating on that element, we always give you that particular element. We call this guy identity element. So x is operating on I to give you x. I is operating on x to give you x. So this I here is an identity element because it's operating on this guy and it's not changing the guy. So you are imputing 2 and you are still getting 2. So that guy that is operating on 2 to still give you 2 is called identity element. And for identity elements to hold, the operation has to be commutative. So we can boldly say that subtraction and division does not have an identity element. However, addition and multiplication has identity element. So how can we determine the identity element of addition, and how can we also determine the identity element for multiplication? So let's do that. That should be the first thing we'll look at. Identity element for addition. So addition, identity element. So we just said an element, let's say x, we operate. Now our operation is addition. We operate on identity element to give me the same x. It can also come in the form of I. We operate on x to still give me x. So whichever one you want to use should give you exactly the same answer. That's what the rule is stating. So if x is operating on the identity element to give you x, where the operation is addition, so from here we can boldly say that my identity element is equal to 0. So the identity element of addition is equal to 0. Now is that correct? I believe that's correct because if you pick out 5, operate it on 0, the operation is addition, this will give you 5. So you can see that this is an identity element because this element did not change. Pick out minus 20, add 0 to it, it will also give you minus 20. So you can see that the identity element of addition is equal to 0. Identity element of addition is equal to 0. Now let's move on to multiplication. Identity element for multiplication. So it means that x will operate on identity element to give us x. X will operate on identity element to give us x. So what will be the identity element? Identity element must be equal to x over x, which is equal to 1. So I can boldly say that 1 is the identity element for multiplication. Identity element for addition is 0. Identity element for multiplication is 1. So we can check, pick 5, multiply it by 1, it will give you 5. Pick 22 over 7, multiply it by 1, it will give you 22 over 7. So you can see that for multiplication, 1 is the identity element. And also for an element or for an operation to have an identity element, that operation has to be commutative. Always remember that an operation that is not commutative can never have an identity element. Now let's look at the question on the board. Find the identity element of the set of real numbers R under the operation defined by P operation Q is equal to PQ over 3. So we have to find the identity element. And I just said for this guy to have an identity element must be commutative. So from what you can see, is this commutative? Yes, it is commutative. But let's prove that this is commutative. For this guy to be commutative, P operation Q must be equal to Q operation P. You already know that P operation Q is PQ over 3. So Q operation P, it means that in place of P, I'll be taking Q, and in place of Q, I'll be taking P. So this guy here will turn to QP all over 3. So is there any difference between this and this? There's no difference. 2 times 3 over 3 is not different from 3 times 2 over 3. So if P is 20 and Q is 7, this will be 20 times 7 over 3, which is 140 over 3. This guy will be 7 times 20 over 3, which is also 140 over 3. So you can see that this operation is actually commutative. Now that we know that it is commutative, what is the identity element? What is the identity element? We have to follow the rule. We have to follow the rule that states that one of them must operate on identity elements to give you exactly the same element. So let's work with P. P here must operate on identity elements to give you P. P must operate on identity element to give you P. You can also work with Q. Q must operate on identity element to give you Q. So whichever one you work with here will give you exactly the same identity element. Now you can see P is operating on identity element to give you P. Now this guy must obey the rule of the operation. And what is the rule of the operation? First guy operating on second guy is equal to the product of the two guys over 3. The product of the two guys over 3. We are going to do the same thing here. The product of the two guys is Pi all over 3, and this must be equal to P. We can boldly say that P here will cancel P. So if P cancel P, so I will be equal to 3. So I'll multiply both sides by 3. My identity element will be equal to 3. So if I also work with Q, my identity element will also be equal to 3. Now, how do we prove that what we are saying is correct? Pick out any element, operate it on 3. It should give you that same element because identity element is 3. So if I pick out 30, operate on 3, it should give me 30. If I pick out 7, operate on 3, it should give me 7 as long as I'm dealing with this operation. So let's bring out the operation again. P operation Q is equal to PQ over 3. Now, let's operate 7 on 3. We just agreed that 3 is the identity element. So this should give us 7 because an element operating on identity element should give you that same element. So this should be 7 multiplied by 3 all over 3. 3 cancel 3 and the answer is 7. So we can agree that 3 here is the identity element. So that's how you solve questions, or that's how you look for identity elements. Now next video we'll be moving on to inverse elements. So what you should take from this video is that for a set, for an operation to have an identity element, that operation must be commutative. That operation must be commutative. So thanks for watching. Kindly use the like button, subscribe button, and the share button. See you guys in my next video.